Okay, so this is going to be a video about an algebra concept called completing the square. So typically in algebra, you want to solve equations, and there's different methods of doing it. And one of these methods is called completing the square. Sometimes you don't get the answer from it. Sometimes you just turn everything into a what's called a nicer form. So in this case, what I'm going to do is I'm going to take what equation should I do? Let's just say, x squared minus 10x is, let's just say, equal to 9. Okay. And actually, you know what? Let's make this, no, let's keep it like it is. So this will be our original problem. And there's different ways of solving this, right? You can factor it. You can use the quadratic equation for it. All sorts of different methods. And really what the completing the square method says is you're going to take this number here in the middle. You're going to take this number in the middle, divide it by 2, and then square it. And whatever number you get, you will be adding to both sides of the equation. And there's a reason for that. So before we do that, before I explain it, let me go and let's actually do it. So again, we're going to take the middle number, the one that's multiplied by x, divide it by 2, and then square it. So we know that 10 divided by 2 is 5. 5 times 5 is 25. So now we're going to have x squared minus 10x. Whatever number we get, we're going to add to both sides of the equation. It's going to be plus 25 equals 9 plus 25, right? Cool. So what this is going to look like now is the reason why we did this is we now have ourselves a little cute algorithm here on the left-hand side. So we have x squared minus 10x plus 25. We understand if we factor this, this is really just the same thing as x minus 5 squared is equal to 9 plus 25. Well, 9 plus 25, that's just equal to 34, right? And so it's equal to 34. And from here, we can actually use this to solve the equation. So we can do that by taking the square root of both sides. And if I do that, I'm going to get rid of this 2 here, and this thing's going to turn into a radical. So if I take the square root of both sides, I get x minus 5 is equal to the square root of 34. Now I want to solve for x. I will add 5 to both sides, plus 5, plus 5. This is going to get me x is equal to a positive 5. And when it comes to radicals, we always have to remember that it has to be positive or negative. So it's going to be 5 plus or minus the square root of 34. So this will be our final solution. You should have 2 solutions. Whenever you have a quadratic that is raised to a second power, you'll always have 2 solutions. If it's raised to a third power, you'll get 3 solutions, fourth power to a fourth. It goes on and on. So that is how this guy kind of works. And so let me try this again. Let's just do another example here. Actually, you know what? Let's go to a different page. Cool. So let's just do one where it's, say, x squared plus 2x is equal to 0. Okay. So we want to do completing the square method for this. Again, you could solve this, and there might be easier methods of doing this, but we want to do completing the square method for this quadratic. So remember the algorithm, divide the middle term by 2, divide whatever is multiplied by x by 2, and then square it. So in this case, 2 divided by 2 is 1, 1 squared is 1. We add that number to both sides. So x squared plus 2x plus 1 is equal to 1. And this, we know, is going to factor perfectly into x plus 1 squared is equal to 1. Now, let's go and let's take the square root of both sides, take the square root of this side, you're going to get x plus 1 is equal to, and here, what's the square root of 1? Well, the square root of 1 is just 1, right? But remember, it could be a positive 1 or a negative 1. So let's just do positive, negative 1 in this case, right? And so let's get this 1 to the other side, subtract 1, you get x is equal to negative 1 plus or minus 1. So we're going to have two solutions, and we can solve for them. So here, let's take the positive 1 case. So we have negative 1 plus 1. It's going to give us 0. Let's take the second case, which is negative 1 minus 1, which is going to be equal to negative 2. So we have 0 and we have negative 2. If these two things are our solutions, we should be able to put them back into the equation and get 0. So if x is 0, that means the first term is 0. The second term is 0. So 0 plus 0 is equal to 0. So 0 plus 0 is equal to 0. Checks out, right? Cool. So what about the second one? So if we put in negative 2 for the first one, now we have negative 2 squared plus 2 times negative 2 should be equal to 0. Well, negative 2 times negative 2, positive 4. We're going to have a 2 times a negative 2 is just negative 4. It's equal to 0. 4 minus 4 is 0. 0 is equal to 0. It checks. So these are our two solutions for this, completing the square method. So to kind of reiterate this, let's just say completing, I'm sure I'm butchering the English, completing the square method. Completing the square method. Okay. Let's do this all mathematically like. So let's assume we have x squared here. We're going to have x. You know what? No. Let's just do it actually easier. Take the coefficient. That just means the number that's in front of any variable. So in this case, it will be the variable x. Take the coefficient of the x term. Take the coefficient of the x term, right? The one that's in the middle. Step 2. Divide it by 2. Step 3. Square it. Square that same number. That same number. Fourth, add that number, positive or negative. Add that number to both sides. Both sides of the equation. Fifth step, solve your equation. Solve your equation. So hopefully that makes sense, right? Let's see if I can maybe do one more just so I can kind of clarify everything. Let's just say we have, let's just say we have another x squared minus, let's do 6x is equal to 7. Cool. So one really important thing to note is that completing the square method doesn't always necessarily work. It works in certain cases. So for instance, we can use it on this equation, but let's just say that this first term here, if it were multiplied by any number besides 1, let's just say in this case 2, we couldn't use it. In that case, we'd have to find another method to use it. So it's only good for if this first term is being multiplied by 1, but because it is, we're allowed to use it. So in this case, let's take the second number, divide it by 2, and square it. So -6 divided by 2. So it's just 6 divided by 2 is 3. Squared is 9. So we should get, we're going to add that to both sides. So x squared minus 6x plus 9 is equal to 7 plus 9. And the right-hand side is going to be equal to 16. And we know that we can perfectly factor this out into x minus 3 squared. Cool. And we can solve for this automatically. I'll just do it here really quick. I know it's going to be x minus 3 is equal to positive or -4. X is equal to, I'm going to add 3 to both sides. 3 plus or minus 4. I know one of my answers is going to be equal to 7. I know one of my other answers is going to be equal to -1. So I will leave that up to you to basically prove that, but that is some basic stuff for completing the square.